Hello and good afternoon to everyone. My name is Nikolina Goles and I'm a PhD student from Faculty of Electrical Engineering and Mechanical Engineering and Naval Architecture in Split. And I'm proud to say that I'm a president of ASHRE student branch in Split, University of Split, and that is the first ASHRE student branch in Croatia. I'm very happy to be here today, and I want to thank Professor Maria Todorovic and Professor Branislav Todorovic for inviting us here and for giving us this opportunity to present our works. My paper is named Impacts that are contributing to a gap between designed and achieved energy savings in buildings, and it is made by my professor mentor Sandro Nižetić and myself. Okay, I will make a short introduction to the paper itself, then I will tell you which are the impacts that are causing a gap between designed and achieved energy savings in buildings. Then I will introduce you to the concept of the novel building evaluation methodology, and in the end you will be able to ask me some questions based on made conclusions. Okay, as we all know, buildings are responsible for around 30% of overall primary energy consumption, and as well for around 40% of CO2 emissions. Transport and industry is less. So that is why energy efficiency projects are so important. They are key drivers to spur new and sustainable economic growth in the European Union. And today the most used indicator in case of the buildings is energy certificate, but it's not realistic indicator because it is based on static data, and it's very hard, it's not impossible, but it's very hard to standardize buildings. So that is one of the reasons why we have this difference between designed and achieved energy savings. We can divide the impacts into two main groups, technical and behavioral ones, and they are interconnected, as I will show you now. Okay, so technical impacts, that's design, because every different design of the building it's in the need of the different approach regarding energy efficiency, and we also have to take you can see, and we also have to take in consideration in which climate the building is built in, and we cannot simplify the construction process. Then we have installed equipment, which equipment is installed in buildings, and in what way we are using it, which lead us to equipment exploitation, which is strictly correlated with the human behavior and occupants' habit. As I mentioned before, we have this energy certificate classes from A to G, which European Union has provided, but like I mentioned before, it's static data, and it's not. It doesn't take in consideration human lifestyle, which is important. And we also have other influences, other technical impacts. And as for the behavioral impacts, there is occupants and their habits. It's a big difference between public and private buildings. It's easier to increase energy efficiency awareness in occupants' homes, of course, because in public buildings they often don't think about which devices are turned on and how much energy is wasted. And the best way to measure this occupants' behavior is by monitoring them. Maintenance staff, they have to be well educated, they have to have skills and knowledge to maintain the buildings, and building management mustn't be hard, and personnel has to be well educated as well as maintenance staff. Like in technical impacts, we here also have other influences which are different from building to building. Okay, now I will introduce you to the concept of novel building evaluation methodology. It's based on two main aspects. First one is, even if buildings can be classified in several categories, it is important to understand that each building is singular and it is hard to task to standardize them. And the second, technical and behavioral impacts are correlated, so none of their subcategories can be neglected. This new methodology should contain all impacts that affect a realistic achieved energy savings, or the most influential one. So this achieved energy savings are often lower than designed ones. It's because achieved energy savings are reduced because of this energy efficiency building dissipation rate. In general, this factor is sum of technical and behavioral impact. Technical impact of the contains from design, like we said, from the installed equipment and from equipment exploitation and other influences. And behavioral impact contains from occupants' behavior, management, and maintenance stuff, and also other impacts. These impacts, I don't know if you, okay, these impacts, the last one, they can be omitted. They are used only in special buildings. And this alpha and beta are weight factors. So we can see which has the more weight, technical or behavioral impacts. And we are also here introducing behavioral index. Okay. And for conclusions, in general, impact can be divided to technical and behavioral ones. Technical are more or less predictable, unlike behavioral, which are more complex, but their impact on the energy consumption is significant. So we have briefly introduced novel approach as useful evaluation criteria, which is based on energy efficiency and building dissipation rate, and it contains all previously defined factors. And this approach is currently under the research. That will be my PhD thesis, and I am at the very beginning, I have to say. So this new proposed building evaluation methodology could be used in stage of the economic evaluation of possible investments in specific building facilities, because unlike others, it would give results that are more or less close to reality. Yeah, so thank you for your attention.
Thank you.